Hello everyone. In this video, I'll be going through some slightly more complicated hyperbolas where the hyperbola, for example, could shift up or down. Okay, so first I'm going to go through the hyperbolas that could shift the up. So as you can see, y equals k over x, that's a hyperbola. And if you add a constant after it, all you have to do is shift the parabola, the up. Okay, so the addition of a constant translates the curve vertically. Moving the graph vertically will also change the horizontal asymptote. So as you can see in this graph, the gray line is the graph y equals 3 over x, and we can see that there's a horizontal asymptote and a vertical asymptote. Once we shift the graph up, the horizontal asymptote will also shift up 1 unit. Okay, but the vertical asymptote is unchanged because this is a vertical shift. Okay, so if c is positive, we will move the hyperbola up. If c is negative, we move it down. Okay, so now once you move the hyperbola up and down, the asymptotes will shift. The asymptote will become, the vertical one will be unchanged, x equals 0, and the horizontal one will be y is equal to c. So we'll go over through some examples. Okay, so from this example, this is the graph y equals 3 on x plus 2. So you can see that the horizontal asymptote has shifted up 2 units. So now the new equation for the horizontal asymptote is y is equal to 2. Right? But the vertical asymptote is still going to be x equals 0. This is the hyperbola y equals 3 over x shifted down 2 units. So as you can see that the horizontal asymptote is now y is equal to minus 2. And the vertical asymptote is still the same, x equals to 0. Right. So basically the number that you see here, that will become the new horizontal asymptote. Alright. So let's just go through an example. So sketch y equals minus 4 on x and y equals minus 4 on x plus 3 on the same number plane. Okay. So I'm going to start with y equals minus 4 on x. So to sketch this graph, so like I said, with the basic hyperbolas, the equation of the asymptote is going to be the x-axis and the y-axis. Okay, so now I'm just going to substitute 1 point in the substitute 1 point first. So let's just say x is equal to 1. So what's y going to be? Y is equal to minus 4, right? So you have 1 and minus 4. So 1 minus 4. 1, 2, 3, 4. So this is one of the points. So if you remember from last lesson, so if a hyperbola has a negative in the front, it's going to be in the second and the fourth quadrant. So I'm just going to, so this one is going to be the fourth quadrant. And then find a point in the second quadrant. So we can do is we let x equals to minus 1. And then y is 4. Substitute minus 1 into here, you get minus 4 over minus 1, which is 4. So you have minus 1 and 4. 1, 2, 3, 4. So this is another point that the graph lies on, and you just have to do this. Okay. So this graph is essentially y is equal to minus 4 over x. Now to sketch y is equal to minus 4 over x plus 3, we have to shift the graph up 3 units. So I'm going to use a different colored pen for that. So previously, the asymptote for the old graph for y equals minus 4 on x is, so the horizontal line should be y is equal to 0. Now the new horizontal asymptote will be shifted up 3 units. So it's going to be y is equal to 3. Okay, so I'm going to draw a horizontal line. So it should be around here. So that should be the line y is equal to 3. That's the asymptote. And after finding the asymptote, now because the graph has shifted up, we now have a y-intercept. Okay, sorry, not a y-intercept, an x-intercept. Now to find the x-intercept, we'll let y is equal to 0. Okay, so 0 is equal to minus 4 over x plus 3. Now to solve for this, what we can do is we can add 4 on x to both sides. So we get 4 on x is equal to 3. And to solve for x, what we can do is we can actually swap the x and the 3 around. So we get 4 on 3 is equal to x. Okay. Okay. So this is the x-intercept. Okay. So x is 4 over 3. So then that's like about here. Okay. Now we know that the line will go through this point, so we basically have to shift this graph up 3 units, so it's going to look something like this. Okay. And then for the other side, now what we can do is we can substitute x is equal to minus 1 here. So when x equals to minus 1, what does y equal to? Y equals to 4 plus 3, which becomes 7. 4, 5, 6, 7. Okay. So we know that it's going to go through that point as well. So we know the graph will look something like this. Okay. So basically the lesson to learn from here is that once you move a hyperbola up or down, it's now going to have an x-intercept. So make sure that when you do these questions, you label the x-intercept. So for this one, it should be 4 over 3. Okay. All right. So there we have it. Now, for the next question, now we know that this graph is y equals 2 on x shifted down 3 units. So that means the horizontal asymptote is also going to be shifted down 3 units. So I'm going to draw the asymptote first. So 1, 2, 3. So that's the equation. Y is equal to 3. Oh, sorry, y equals to minus 3. Okay. Now we need to find what the x-intercept is. So we let y equal to 0. So 0 is equal to 2 on x minus 3. We can add 3 to both sides. So 3 is equal to 2 of x. And like I said before, you can swap the 3 and the x around. So you have x is equal to 2 over 3. Okay. So then x equals to 2 over 3. So that's about here. Okay. So remember, and for the vertical, the asymptote is the unchanged. Okay. So we know that the graph goes through here, and we know that because the number in front of the 2 on x is positive, it's going to be the first quadrant and the third quadrant. So the graph will look something like this. Excuse my bad drawing. So it will be like this and like this. And then there will be one that goes through here. But before we do that, let's just substitute a point in where x is negative. So let's just sub in x equals to minus 1. Okay. When x equals to minus 1, y is equal to minus 2, take away 3, which equals to minus 5. So you have minus 1 here, minus 5 here. So you have this point. So we know that with hyperbolas, you always draw in the opposite quadrants. So I'm going to draw the other half here. And there you have it. You've sketched the graph. Now, when it comes to the exam, you don't really have to label the asymptotes if the asymptotes are exactly on the x-axis, the y-axis and the x-axis. So as you can see in this question, I only labeled the horizontal asymptote because it's not on the x-axis. Okay. All right. Let's do the next question. Now, so far we've come across hyperbolas where you shift up or down. These are the types of hyperbolas where you can shift left or right. And the only difference is that you need to make sure that the denominator is x minus b. Right? So if you have a parabola that's shifted up, for example, it'll be y equals k on x. Now the plus is the outside of this, plus b. That's a parabola that's a hyperbola shifted up b units. Whereas here, you have x minus b at the bottom of the fraction. So this is a parabola that's shifted right, b units. Okay. The adding a constant x translates a curve horizontally. Moving the graph horizontally will also change the asymptote. If b is positive, translate b units to the right. So just think of it this way. So you probably still remember that when you have parabolas, you have y is equal to x squared, right? And you remember that when it was y is equal to x, say, minus 2 squared, you remember that this is a shift towards the right, and it's not the left. So make sure you remember this, because some people will intuitively think you shifted to the left because it's a minus, but in these circumstances, you've shifted to the right. And this is the same concept. So if you have a hyperbola where the denominator is x plus 1, that means we know you have to shift the hyperbola left 1 unit. As you can see here, graph moved horizontally, minus 1. And the reason for this is because, think about it this way. What number can x not take? X can't be minus 1, because if x was minus 1, the denominator will become 0, and you cannot divide by 0. Therefore, x equals to minus 1 becomes the vertical asymptote. Okay. Now, because these hyperbolas are only shifted to the left or right, there's no change to the horizontal asymptote. Just like how in the previous example, because they were shifted up or down, there's no change in the vertical asymptote. Okay. So here are some more examples. So this is the graph y equals 3 on x plus 2. So this is essentially the graph of y is equal to 3 over x shifted to the left 2 units, right? Because it's plus 2 here. And this is the graph of 3 on x shifted to the right 3 units. As you can see, it's shifted to the right. So therefore, the asymptote is going to be x is equal to 3 for this one. And here, the asymptote is x is equal to minus 2. Okay. All right, so let's do some sketches. Okay, so sketch the graph y equals minus 5 on x and this on the same number plane. So I'm going to sketch the first one first. So because we know that there's a minus, so it's going to be in the second quadrant and the fourth quadrant. So I'm just going to sub in values here. When x equals to 1, y is equal to minus 5. So 1, 2, 3, 4, 5. So this is 1 point. Hyperbola will look something like this. And when x equals to, say, minus 1, y is equal to 5. Okay. So there's this is the other point. Yeah. Now to draw the next graph, I'm going to use a different color pen. So this is the parabola that's shifted right 2 units, right? So that means that the asymptote is going to be x is equal to 2. So I'll get my ruler here. So this is x is equal to 2. And let's find so because we know that the graph has shifted to the right, now there's going to be a y-intercept, because now x can be 2. So when x is 2, when x equals to 0, what does y become? Y is equal to minus 5 over 0 minus 2. So what does this become? This becomes minus 5 over minus 2, which is 5 over 2. Right? So now we have the intercept of 5 on 2. So this is 2. So this is 5 on 2. And basically, we know that this graph will also be in quadrant 2 and quadrant 4. So you can just draw the graph like this. Okay. Similarly, you have to draw something that looks like that in this quadrant. But before we do that, let's just find out one point. So I normally just sub in x equals to 1. So when x equals to 1 here, you have minus 5. So when x equals to 1, then you have y is equal to minus 5 over 1 minus 2, which equals to 5. Oh, sorry, we shouldn't have substituted that in. We went to substitute a point on that's bigger than 2, okay? So when we substitute x is equal to 2, when x is equal to, say, 3, because we need to substitute a value that's on the right side of the vertical, the asymptote, then we have y is equal to minus 5 over 3 minus 2, okay? And this gives you what? Gives you minus 5. When x equals minus 3, when x equals 3, y is equal to minus 5. So then to draw this graph, it's a little bit confusing because you have the blue, you have the y equals minus 5 on x here as well, but it should look something like that. There you go. So that's the difference between y equals minus 5 over x minus 2 and y equals minus 5 on x. So the red graph will represent y equals minus 5 on x minus 2, and the blue one will represent minus 5 on x. All right. Here we have one more example. Sketch y equals 4 over x minus 1. So like I said, before we do these questions, find the asymptote first. So this is a graph. So what value can't the x be? X cannot be 1, right? So therefore x equals 1 is the asymptote. So this is the asymptote of x is equal to 1. And now we determine which quadrants it's in. So because the number in front of the 4 is positive, so it's going to be in quadrant 1 and quadrant 3. So to find a point in quadrant 1, what we can do is we can substitute a value. So we can substitute the x equals 2. Okay. So x equals 2. What does y become? So y becomes 4 over 2 minus 1, which is 4. So that's 1 point. 2 and 4. And we also have to find the y-intercept, right? So to find the y-intercept, we'll let the x equals 0. So when x equals 0, what does y become? Y becomes 4 over 0 minus 1, which is minus 4. So 0 minus 4 is also is an intercept. So now we basically sketch the hyperbola. So we go through this point, so it will look something like this. And then this will go through that point, so and there you have it. Okay. Now the next one is a combination of what we learned so far. So this involves both a horizontal and a vertical strip, and they can be combined. So in a graph like this, that's basically y is equal to 2 over x. So we start with this graph. If it's plus 3 at the bottom, we shift left 3 units, and then we shift up 1 unit. Okay, so that's how these kind of graphs work. It's a combination of a horizontal and a vertical shift, and because of that, both the asymptotes are going to change. Okay, so here this asking you to find what the asymptotes are. So you can see that the horizontal asymptote, because the graph has shifted up 1 unit, the horizontal asymptote is going to be y is equal to 1, and the vertical asymptote is going to be, because the graph is shifted left 3 units, it's going to be x is equal to minus 3. Now for this one, this one's a little bit more confusing, mainly because the number is in the front, but you don't really need to be afraid. This is the same as this. When you have y is equal to 3 minus 2 on x minus 2, this is the same as writing it as minus 2 on x minus 2 plus 3. Okay. So as you can say, this is a hyperbola that's shifted right 2 units. So as a result, we can say that the asymptote is x is equal to 2. And this is a hyperbola that's shifted up 3 units. So you can say that the horizontal asymptote is y is equal to 3. So hopefully you're able to do these questions without looking at these graphs, because these answers are already given to you by the picture. And this question asks you to sketch y is equal to 4 over x minus 1 plus 2. So I'll go through this with you. So like I said, when you have an x minus 1 on the denominator, this means the graph is shifted to the right 1 unit. If it's shifted right 1 unit, then you know that it's going to be a vertical line that goes through 1. So that's the equation. X is equal to 1. Now we know that the hyperbola is also shifted up 2 units. If it's shifted up 2 units, then we know that the horizontal asymptote is going to move up 2 units. So it's going to be y is equal to 2. To find the x-intercept, we let y equal to 0. So 0 is equal to 4 over x minus 1 plus 2. So to solve for this, we can take away 2 from both sides. So we take away 2 is equal, minus 2 equals to 4 over x minus 1. And like I said earlier, so you can swap this number and this number around. So you're left with x minus 1 is equal to 4 over minus 2. And we know that that's equal to x minus 1 is equal to minus 2. So what does the x equal to? We add 2 to both sides. So x is equal to minus 2 plus 1 is minus 1. So that's your x-intercept. Now to find the y-intercept is normally easy to do because you just have to substitute 0 for x. So y is equal to 4 over 0 minus 1 plus 2. So this becomes minus 4 plus 2, which is minus 2. Okay. Alright, so let's put in all the information that we have now. So we have 2 asymptotes, x equals to 1. So that's this line here. I'm going to draw a straight line. And be careful you don't get this mixed up, alright? So when you have a vertical line, it's always x is equal to something, and a horizontal line is y is equal to something. And this is the line y equals 2. Okay, so make sure you draw the arrows because the line keeps on going. X equals to minus 1. Oh, sorry, x equals to 1. Y is equal to 2. Alright, now we label the x and y intercepts. So the x intercept is minus 1. Y intercept is minus 2. Okay, so because the number in front of the 4, that's a positive, right? So we know that it's going to be in quadrant 1 and quadrant 3. Okay, so that means, so I'm just going to draw the quadrant 3 one because we already have 2 points. So it's going to be something that connects these 2 dots. Okay, so you should draw a better looking one than I do because I'm doing this on the computer. And to find a point in quadrant 1, we can substitute a value of x that's greater than 1. Okay, so we can substitute x equals to 2. So when x equals to 2, what does y equal to? So you have 4 over 2 minus 1, which is 4, plus 2 gives you 6. So when x equals to 2, y equals to 6. So 1, 2, 3, 4, 5, 6. There we go. So then we just draw a line that goes to this point in the first quadrant. And there we have it. How to sketch a complicated hyperbola. Here's one more example that I'm going to go through, but hopefully by now you should understand how it all works. So I'm just going to quickly go through this example. So to find the asymptotes, we know that this is a parabola that shifted left 3 units. So that what value can x not take? X can't be minus 3, right? It's also shifted down 2 units. So that's y is equal to minus 2. Now to find the x-intercept, let y equal to 0. So 0 is equal to minus 5 on x plus 3. Minus 2. We add 2 to both sides, so you get 2 is equal to minus 5 over x plus 3. Now you can do the switcheroo here. X plus 3 is equal to minus 5 over 2. And take away 3 from both sides, so x is equal to this number take away 3, which gives you what? Minus 11 on 2, right? You can use your calculator if you want. Now to find the y-intercept, let x equals 0, so this is the easy one. Y is equal to minus 5 over 0 plus 3 minus 2. If you use your calculator, what you should get is this should be minus 5 on 3 minus 2. So I'm going to use my calculator. Minus 5 on 3 minus 2. So this is minus 11 on 3. Okay. Okay, now let's just put in the information here. So x equals to minus 3. Draw a vertical line. Bam, there we go. And then draw a horizontal line for the horizontal asymptote, y equals to minus 2. Bam, there we go. Okay, so x equals to minus 3. Y is equal to minus 2. Now, because we know that this hyperbola has a minus in the front, so we know it's going to be in quadrant 2 and quadrant 4, right? Without even sketching this, I already know. So let's label the x and y. So x equals minus 11 on 2, which is minus 5.5. Okay, so 1, 2, 3, 4, 5, somewhere here. So the y-intercept is minus 11 over 3. So this is slightly below minus 3, as you can see from here. Okay, so we already have the 2 points in both of the quadrants because they are the intercepts. So we just have to draw lines that cross them. So this is one of the lines. And the other line will be in this fourth quadrant thing. Okay. Alright, so that's how you sketch hyperbolas. In next lesson, I'm going to go through and help you find the equations of hyperbolas. Alright, enjoy.